Hello everyone, I'm Bolin from National University of Defense Technology. Today my topic is Automotive Common Update How Far We. This is our collaboration with researchers from NUA and the University of Luxembourg. This table shows a real-world example of command updates in the API main project. A commit changes the second parameters of create connector from service to API. Similar change happened in the type of connector. Initially, the project developer only updates the code while forgot to update the command associated with this method. Such bad commands can have a negative effect on the program comprehension and maintenance. Recently, Liu et al. Have proposed COP as an automated just-in-time command update technique to cope with the bad commands. Their core idea is that inconsistencies can be avoided if commands are automatically updated with each code. COP has shown its advancement that has achieved huge improvements over zero baselines. While about current command update techniques, little is known about how well and why they work or don't work. To fill this gap, we prefer an assessment that analyzes the strengths and weaknesses of the COP techniques in depth. In this session, we define three indicators to measure the distance of the code and the command change. As defined in this slide, NCS means the number of the changed subtokens. Here is an example of code change. We're using a laser to tokenize the code and label the code change. The NCS code in here is 3 for layer 1 delete and 2 insert in the action sequence. Here is the first research question, the characteristic of dataset. From the angle of code change, we observe similar distributions of NCS code and the NCS command among three sets. The indicators in the both plot are similar. We also compare the two indicators of cases from test and the correct set. This time, we observe obvious difference within the distribution. The median value of NCS code in correct set is only about half of test set. Similar statistics result in NCS command. This shows the distributions on training, validation, and the test set are similar, while the correct cases are much simpler than the test cases. Here is the research question to recap performance on cleaned dataset. The author of COP defined two new indicators to evaluate the performance of COP, which is AED and RED. We observe the performance of COP on the cleaned dataset is comparable with that from the original dataset. The four values only experience minor changes. This result shows switching to a cleaned dataset does not result in a significant reduction in the performance of COP. In this article, we try to find out where and why does COP work well. First, we find COP is far more effective on single token and single subtoken updates on all cases. Its accuracy is 31.8% and 27.8%. respectively, nearly twice as the average value on the whole dataset. Furthermore, if we focus on correct update items, nearly half updates are single subtoken update, and a huge amount of correct command updates are generated for single token update. This is where we catch the first intuition for our tools. Similarly, almost all correct updates are code indicative single token or subtoken update. Here we get our second intuition. Nearly all correct updates are code indicative ones. A typical field example is given in here. The newly added token in the command does not appear in the code change part but in the unchanged part. However, COP pay more attention to the changed part and it's hard to predict the newly added token in the unchanged part. Here is the major cases of the failures. cup can borrow the relevant content directly in the code change. There are another two cases shown in our paper. Following the previous intuition, we designed a heuristic-based command update, namely hubcap. Hubcap first identifies the unchanged part, which is getRight bar line and getRight bar line in this case. The following step is subtoken alignment and replacement pair construction. It aims to find out the changed subtoken and construct replacement pair. Hubcap constructs replacement pairs by enumeration. Then we sort the replacement pair candidates by the number of subtokens they own. The behind intuition is the token with more subtokens can have more semantic information and is more likely to appear in the command. The last step is matching and update. Hubcap travels tokens in the old command and use the corresponding value to update it. We compare the hubcap with the cap regarding effectiveness and efficiency on our cleaned dataset. The first table reveals that hubcap outperforms cap on all metrics. Specifically, its accuracy value is about 16% higher than the cap. The red value decreases to lower than 0.9, which indicates that it can better help developers to reduce the manual effort on command update. According to the second paper, CAP spent more than 8 hours to training and testing, while hubcap only took 17 seconds to generate the updated command. This means hubcap is more than 1700 times faster than CAP. This paper performed an empirical study on automatic command update and proposed our tool demo, namely hubcap, according to our empirical findings. All data is publicly available on GitHub. That's all. Thank you. Namely,
Hi.
Hi.
This was the presentation of the automated comment update. How far are we? We have one question from Shulin. There's another paper, Learning to Update Natural Language Comments Based on the Code Changes, focus on comment updated in ACL 2020. Why this paper only focuses on CUP cap, rather than these two papers both?
Yes, we focus on there's another paper on ACL, which title is Learning to Update. But we only focus on CUP, which appeared in ASE 20, mainly for some reasons. Firstly, the main reason is the CUP is more famous. So we focus on this paper. Firstly, it's the distinguished paper in ASD 20. The second reason is that the CUP has more than 100,000 items, but the paper on ACL is only provides about I remember that it only provides 10,000 items. So for deep learning techniques, we think that it's not enough cases. So we to better investigate these techniques, we decided to focus on CUP and believe that the more cases and more better paper can help us to understanding these techniques and make interesting finding to help the community. Yes.
Mm-hmm. Thank you. Any other questions? I have a small one. In research questions, for answering research question 3, you have investigated that the existing approach works well for the cases of number of the token is only 1. But yes. What is the distribution of the number of tokens in general? So how many tokens should the technique focus on?
Yes, we finding that the most token can be updated is they only change one token, but more token we believe that they can give some more